So let us solve a few more numericals on this topic of vectors. So this numerical, particular one, is in the example number 10 of my book. The question says that there are two vectors, vector A and vector B, and the given information is that the sum and the difference of the two vectors are equal in magnitude. So sum of the vectors is equal in magnitude to the difference of the vectors. Question says prove vector A is perpendicular to the vector B. That is what the question has asked us to prove. So how do we do this? Well, we know one thing, that if 2 is equal to 2, then 2 square is also equal to 2 square. So using that basic thing, what we can take, we take this one, this is given that these magnitudes are equal, we take the squares. So mod of vector A plus B square is equal to mod of vector A minus B square, because these two are equal. Now what formula, another one we know that if there is a vector S, then dot product of the vector S with itself, which is also known as the self product, is equal to magnitude of the vector square. You will find this in your book. So if there is a vector S, if we take the self product of the vector, that is we take the dot product of the vector with itself, it is equal to the magnitude of the vector's square. So here we have the magnitude of the vector square. So this is basically vector A plus B dotted with vector A plus B. Similarly, this is vector A minus B dotted with vector A minus B, using this one. Now if we do the dot products here, dot product is distributive, so all the components can be separately written as A dot A plus B dot B plus A dot B plus B dot A, and this thing will be A dot A plus B dot B minus B dot A minus A dot B. Now A dot A and B dot B get cancelled on either side. So what we have, A dot B plus B dot A, which is nothing but 2 times A dot B, because again it's a rule of dot product that if there are two vectors A dot B, it is same as B dot A, because the vector product is commutative, the scalar product is commutative. So 2 times A dot B is equal to minus 2 times A dot B. Bringing it to this side, it is 4 times A dot B, and that's equal to 0, because nothing is here, it's 0. So from there we get vector A dotted with vector B is equal to 0. Whenever the dot product of two vectors are 0, what we can conveniently write is the vector A is perpendicular to vector B provided magnitude of A not equal to 0, magnitude of B not equal to 0. Because dot product of two vectors means the magnitude of the first vector times magnitude of the second vector times cos theta. So if magnitude of A or B turns out to be 0, then obviously the dot product will be 0. So you need to write this down, that provided the magnitudes are not 0, then the only thing that can be 0 is cos theta, for which theta has to be 90 degree, hence proved that they are perpendicular. So this is another trick. I provided this sum as an example so that you can know how to use self product in certain proofs. Let us move on to another sum. This is sum number 16 in my book. The given information is that there is a vector A. There is a vector A, and A is minus 2 I cap plus 2 j cap minus k cap. And then there's a vector B, which is 3 I cap plus 6 j cap plus 2k cap. Now just by your intuition, if you do a rough calculation, minus 2 into 3 is minus 6. This is in your head. 2 into 6 is 12 and minus 1 into plus 2 is minus 2. So that makes it minus 8 plus 12, so that's 4. So not equal to 0. So obviously these two vectors are not perpendicular to each other. Why did I check this? Because the question says find theta, the angle between the two vectors. Now if the dot product turned out to be 0, then obviously it would mean that they are perpendicular. So I just did this in my calculation. Now since it is not 0, that means we have to do it explicitly. So what's dot product of A dot B? That's the modulus of A times the modulus of B times cos theta. So therefore, if I make cos theta to be the subject, it is equal to the vector A dotted with vector B divided by modulus of A times modulus of B. Alright, so what's A dot B? A dot B is equal to, if I do the dot product, we did it just now, it turned out to be 4, minus 2 into 3, that's minus 6, plus 12 is 6, minus 2, that's 4. And what is the magnitude of A? Like previous, it is root over of minus 2 squared, that's 4, 2 squared, that's again 4, and minus 1 squared, that's 1. So this is root over of 9, so magnitude is 3. And similarly, magnitude of B is 3 squared, that's 9, 6 squared, that's 36, and 2 squared, 4 under root, so that's root over of 49, which is 7. So I have the two magnitudes. If I substitute here, A dot B is 4 and the magnitudes are 3 times 7, so it is 4 by 21. What is the value of 4 by 21? In class 11 you should be having your scientific calculators. So 4 divided by 21 as per decimal places is 0.19. Therefore theta is equal to cos inverse of 0.19. This is something you can do in your scientific calculator when you have one. It will give you a value of 79 degrees. So easily you can find out what is the angle between the two vectors. This is another type of sum. Let's check, let's do another sum. Let us do one on probably cross product. Okay, so this one. This is question number 26 in the examples of my book. The question says that the adjacent sides of a parallelogram are I cap plus 2j cap plus 3k cap, and the other side is minus of 3i cap minus of 2j cap plus of k cap. Now if you have a parallelogram, what is the formula that you used to use to find out the area in geometry? If this is the base and this is the height, you would simply multiply the base times height. That would give you the area of the parallelogram. In vectorial notation, if you have two vectors, then how will you find out the area of the parallelogram? The area is simply the cross product of the two vectors. So if this is suppose vector A and this is suppose vector B, cross product of A and B will give me the area, not simple multiplication. How do we do cross product? I showed last day. You take I cap, j cap, k cap in the first column, the unit vectors. In the second column you take A, the coefficients of A, that's 1, 2, 3. In the third column you take coefficients of B, that's minus 3, minus 2, plus 1. Now let us find out the answer. So I cap, cover this column and this row, that's 2 into 1, 2. Minus of minus 6, that's plus 6. Minus j, sign reversal, hiding this column and this row, that's 1 into 1, 1. Minus 3 into minus 2, that's plus 9. Plus k cap, hiding this column and this row, it's minus 2 into 1, minus 2. Minus of minus 6, that's plus 6. So it becomes 8 I cap minus 10 j cap plus 4 k cap. This is the cross product vector A cross B. This is the vector which gives us the area. But how do we know the magnitude? Well, you already know how to do it. Root over of 8 square plus minus 10 square plus 4 square. Whatever value turns out, that is the scalar magnitude of the area of the parallelogram. So if you are given a parallelogram whose adjacent sides are known to you and you are asked to find out what is the area, first of all you will have to do the cross product to find out the resultant vector giving the area. For that vector again you use this formula and find out the area. I am not finding out the area for this particular one, I leave it to you. I know you will be able to do it.